Number 12, we have y equals 4 to the x, and we want to graph it. So when I'm graphing exponentials, I only pick 3 points, and that's 1, -1, and 0. So 4 to the first power is going to be 4. 4 to the 0 power is 1. And 4 to the -1 power, and you just take that reciprocal, and we get 1/4. So I have the point 1, 4, 0, 1, and -1, 1/4. So really, that's all the energy you should put into graphing that when you come across them. Okay, number 13, we have log base 3 of the 4th root of 3, and they want us to find the value of the expression. So I'm going to do a rewrite, and log base 3 of 3, and the 4th root is written to the 1/4 power. So I can multiply that 1/4 out front. Remember the 3 properties of logarithms. If you forget, go back and look at your notes for those. Log base 3 of 3 means 3 to what power is 3, so that's just equal to 1. So this just simplifies to 1/4. Number 14, we're solving. So I have log base x of 16 is equal to 2. So I need to do a rewrite and write this as an exponential instead of a logarithm. So this is the base. This is always the exponent, and then it's called the argument. That's what it equals. So when I do the rewrite, it's x to the 2nd power is equal to 16. So if x squared is equal to 16, I'm just taking the square root of it, and I get x is 4. Now normally, we know that 4 squared and -4 squared are both 16, but we can't have a negative base for a logarithm, just like we weren't allowed to have a negative base for an exponential. So my answer is just going to be 4. All right, 15. 4 to the -x is equal to 1/256. I can write these with the same bases. So 4 to the -x. Well, I know 256 is 4 to the 4th. So 1/4 to the 4th. But I want to rewrite that. So I have my 4 not in a denominator. When I bring it up top, that exponent becomes negative. So I get 4 to the -x is equal to 4 to the -4. So that means -x has to equal -4. Divide both sides by -1, and I get x is equal to 4. Number 16, I don't have that. Like, I can't rewrite these with the same basis, so I have to use logarithms to solve this. So I'm just going to take the log of both sides. So I get log of 7 to the x equals log of 3. That x gets multiplied out front. So x is times the log 7 is equal to the log of 3. At this point, I want to get x by itself. So I'm going to divide both sides by log 7. And that's the exact answer. If they want an approximate answer, then I'm going to plug it in my calculator. I use LOG, which means the log base is 10. Remember, your calculator only has log base 10 and log base E, which is the ln. So be careful of that when you're plugging it in. You could use either one, but I'm just plugging in log 3 divided by log 7. And I'm rounding to 3 decimal places. So 0.565. So again, this is exact, and this is approximate. All right, number 17. Log of x plus 9 equals 1 minus log of x. So because I have logs on either side, I'm going to pull this over. And I'm going to rewrite it as log of x plus 9. Add that, so it becomes plus log x is equal to 1. So again, back to my properties. If these are added, when you put them together, it becomes a multiplication. So log, and I'm just going to multiply that out, x squared plus 9x is equal to 1. At this point, I'm going to be able to rewrite it as an exponential. Since it's just log, that means base 10. So 10 to the first power is equal to x squared plus 9x. Move that 10 over. And then we can factor it. So that factors to x plus 10 times x minus 1. So my solutions are negative 10 or positive 1. So back here to the original, it can't be negative 10 because we can't have 10 to some power equaling a negative 1. So that one I have to throw out. So my solution for this, well, let me check the 1. That's okay there, and that's okay there. So my solution to this is x is equal to 1. For number 18, we have 7 times the natural log of x is equal to 4. So I'm going to divide both sides by that 7. I get ln of x is equal to 4 over 7. And now I can rewrite it. Because it's ln, the base is e. So x is going to equal e to the 4/7 power. So again, that's the exact answer. And then I'm going to plug it in my calculator to get an approximate. And again, rounding to 3 decimal places, I get 1.771. Let's go to 20 on here. Did I skip? Oh, I skipped one. I'm sorry. I'm at 19. So I have log base 9 of x minus 2 plus log base 9 of x minus 2 is equal to 1. So I can put these back together. The addition, when you put it together, becomes a multiplication. A subtraction, when you put it together, became division. So I get log base 9 of x minus 2 times x minus 2 is equal to 1. And then I can do a rewrite, and then I'm going to multiply that out as well. So 9 to the first power equals x squared minus 4x plus 4. Set this equal to 0, so subtract 9 from both sides, and we get x squared minus 4x minus 5. So that factors to x minus 5 times x plus 1. So one solution is 5, and the other is a negative 1. Again, this negative 1 is not going to work when you plug it in because you'd have a negative argument. So I have to throw that out. So my answer for 19 has to just be the 5.